Hello everyone, welcome to my channel. So this class is chapter 6 part 3. इससे पहले हम लोग दो पार्ट ऑलरेडी कर चुके हैं जिसमें हम लोग टोटल 12 क्वेश्चन सॉल्व कर चुके हैं. आज हम लोग स्टार्ट करेंगे क्वेश्चन नंबर 13 से. सो 13 क्वेश्चन, पहले क्वेश्चन लिख लीजिए. मैच द फॉलोइंग रेट कॉन्स्टेंट्स. मैच द फॉलोइंग रेट कॉन्स्टेंट with reaction with respect to WRT with respect to substrates. बेसिकली एक्चुअली ऑर्गेनिक क्लेडन में कोई क्वेश्चन के फॉर्मेट में दिया नहीं है. मैं एक्चुअली आप लोगों के लिए क्वेश्चन के फॉर्मेट में बनाया हूँ, इसलिए क्योंकि आप अगर क्वेश्चन के फॉर्मेट में आप क्वेश्चन सॉल्व करने के लिए ट्राई करेंगे तब एक्चुअली आप सोचेंगे कि मतलब क्या क्या हो सकता है, क्यों नहीं हो सकता है, एक क्यों हुआ, दूसरा क्यों नहीं हुआ, इस तरीके से. इस वजह से मैं इस तरीके से क्वेश्चन आपको करा रहा हूँ जिसमें आप लोगों का ब्रेन का इफेक्ट बहुत ज़्यादा रहेगा. वाटर, आपको पता है दिस इज़ ए कार्बोनिल ग्रुप एंड वाटर अगर ऐड होगा सो बेसिकली क्या होगा. Water is having the lone pair, oxygen is having the lone pair of electron, so lone pair of electron will attack into this and it will forming the O minus and then it will abstract the proton from the water itself. चलो एक बार करके दिखा देते हैं. So this will be having, since oxygen has donated the electron density, so it will be having the positive charge and this will be having the O negative. So now इसके बाद क्या होगा, O minus will abstract this proton and positive charge will be diminished. So R or OH. So this is basically a reversible reaction. Why that is so? Because if you again add acidic water with respect to it, then again water will be eliminated and will be getting the ketone as a product. So basically you can give a equilibrium sign to it. RCOR dash, equilibrium sign to it, alcohol. There will be 2H group. Now I am writing the substrates. First one is aldehyde. Second one is the fluorine. C is the ketone. D, Cl, and E is the aldehyde. Okay. Now the equilibrium constants are given 0.01, 1.06, 2280, 1.2 into 10 to the power 6, 2000. This is 0.001. Okay. And fifth one is, okay, 1 2 3 4 5th. Okay, फिफ्थ वन हो गया ना. ठीक है. अब ये बहुत इंपॉर्टेंट क्वेश्चन है क्योंकि देखो, सो हम लोग देखेंगे नाउ, हम लोग देखेंगे इलेक्ट्रोफिलिक सेंटर. सी वाटर इज हैविंग द न्यूक्लियोफिलिक सेंटर since oxygen is having the lone pair of electron. So lone pair of electron will attack into this carbonyl group. So ऑक्सीजन का लोन पेयर ऑफ इलेक्ट्रॉन तब अटैक करने के लिए इंटरेस्टेड होगा जब इसका इलेक्ट्रॉन का हुक ज़्यादा होगा. दैट मीन्स इट्स इलेक्ट्रोफिलिसिटी should be higher. Now electrophilicity, how it will be increased? If there is having electron withdrawing group. Suppose if R groups are attached with the electron withdrawing group, then its electrophilicity will be very much higher. Okay. So now we have to understand where the electron withdrawing groups are maximum. See, so we can understand that electron withdrawing group are this and this, and fluorine is having higher electronegativity than the chlorine. So fluorine will be having the higher at electron attracting power. That's why fluorine takes up the electron density from this particular carbonyl group. And here is you can see that there are 6 fluorine group attached with the carbon, and that carbon was attached directly to the carbonyl carbon group. So this all of the fluorine groups are withdrawing the electron density from this carbonyl. This is getting more positive, and nucleophile likes the more positive part. So this is the more positive. More positive means more electrophilic. Because of the higher electrophilicity of this particular group, this will be having the highest equilibrium constant value. So B will be matching with the 4. Are you getting this? So B will be matching with the 4. Okay. Now we'll be given the next. Next one is a fluorine. इसके बाद chlorine आएगा. Since the chlorine is also having the electron withdrawing power, that is the reason because of which chlorine also will attract the electron density from this particular carbon, and that is attached with the carbon and carbon directly. So the electrophilicity also will be higher, but not as much as the fluorine group, right? So that's why it will be having the value. Now we are having the actually इसके बाद है ना, हम लोग को दोनों के बीच में ओके इसके चलो इसमें मतलब आइदर ये होगा और ये होगा, ठीक है, 2280 होगा या 2000 होगा, राइट। इसके बाद क्या होगा, इसके बाद जो फॉर्मल्डिहाइड आर हैविंग द बट हियर another factor also has to be taken under the consideration is the steric hindrance. Why steric hindrance has to be taken under the consideration? Because steric hindrance के वजह से न्यूक्लियोफाइल अटैक नहीं कर पाएगा यहाँ पे that much. It will not be able to that much. But here as you can see hydrogens are there. So hydrogens are very less sterically hindered. So steric hindrance also you have to take under the consideration when you are comparing the equilibrium constant value in between both of the this. So क्या होगा, steric hindrance के वजह से इसका rate constant इससे भी ज़्यादा होगा. So A will be basically 2280 and this will be 2000 and this is 1.2 into 10 to the power 6. Okay, so this has been completed. अब ये हो गया. इसके बाद जो है, इसके बाद देखिए हमें कौन कौन सा बचा, एल्डिहाइड और एसीटोन. So aldehyde is having the one methyl group which is can act as a plus I affecting group. So because of the plus I affecting group, this methyl group donates the electron density to this carbonyl group which reduces the electrophilicity. इसका electrophilicity घटा देगा, इस वजह से ये कम होगा. एंड इसमें 2 मिथाइल ग्रुप है. सो बिकॉज ऑफ द 2 मिथाइल ग्रुप्स इसका इलेक्ट्रोफिलिसिटी और भी कम होगा. सो दैट इज़ द रीज़न बिकॉज ऑफ विच इस कार्बन का कार्बोनिल कैरेक्टर बहुत कम हो जाएगा, राइट. सो दैट इज़ द रीज़न बिकॉज ऑफ विच दिस विल बी हैविंग द लीस्ट कार्बोनिल कैरेक्टर. सो दिस इज हैविंग 0.001 and this will be having 1.06. So I hope you understood the video. If you have any doubt, please ask into the comment section. I will try to elaborate into the next video. Okay. Now let's do the next question. Question number 14. Now, will there be any reaction in between this? यहाँ पे आपको देखना पड़ेगा कि इन द प्रीवियस केस क्या था, एक इलेक्ट्रोफिलिक सेंटर था, एक न्यूक्लियोफिलिक सेंटर था. लेकिन इसमें क्या है, एक ही में दोनों हैं. वन इज इलेक्ट्रोफिलिक सेंटर एज वेल एज न्यूक्लियोफिलिक सेंटर आर प्रेजेंट बोथ इन ए पर्टिकुलर सेम सबस्ट्रेट. सो दैट्स वाई यहाँ पे आपको क्या देखना पड़ेगा, स्टेबिलिटी ऑफ द रिंग form after cyclization. So whether cyclization will be possible or not, the answer will be given whether the ring that is formed after the cyclization is stable or not. Okay. So now here you can see oxygen is having the lone pair of electron. It can act as a nucleophile. So it will attack into this and it will forming the O minus, right? So क्या होगा? Now just give the numbering. Giving the numbering is very very important. Okay. Otherwise you'll be you will be having the problem. So this is 1. Just give the number 1, 2, 3, 4, 5. So 1 is attacking with the 5. So there is a bond in between the 1 and 5, right? So there is a 5-membered ring will be formed. So this, let's suppose this is 5, this is 1, 2, 3, 4, 5. There is a bond in between the 1 and 5. That's why we are making the bond in between 1 and 5, right? So this is carbon oxygen bond formation. And in the 5 there is a hydrogen. We need not to show the hydrogen. हम लोग hydrogen को show करने की ज़रूरत नहीं है. And this is the OH after the workup I am saying, right? So this is the form. And 5-membered ring is stable. 5-membered or the 6-membered ring is stable. So that's why this cyclization will be favored. And इसमें क्या होगा? Intramolecular cyclization. This is called intramolecular cyclization reaction. ओके 14 हो गया. अब एक बहुत इंपॉर्टेंट कॉन्सेप्ट है. मान लो यह एक 3-membered रिंग है. ओके ना अभी हमें बताना पड़ेगा जी वाटर से रिएक्ट कराएंगे. सो दिस विल बी फॉर्मिंग द diol. Okay, now we have to know whether this is favorable or not. Favorable or not. Now how to understand? See, this carbon is having the sp2 hybridization and this particular carbon is having the sp3 hybridization. So in sp2 hybridization, what is the bond angle? In sp2 hybridization, bond angle is 120 degree, and in sp3 hybridization, bond angle is 109 degree 28 minutes. But what is the actual bond angle in the cyclopropane ring? As all of you know, that is a 60 degree. Here is also 60 degree. So basically here for a particular sp2 hybridization, this carbon wants to get the 120 degree but is getting 60 degree. But for this carbon is wanting to get wants 109 degree but it is getting the 60 degree. So we need to see the difference. So if you see the difference, here is a 60 degree, but here if you see the difference is 39 degree. So lesser the difference, higher will be the favorability, the stability. That is the reason lesser is the difference. So difference is lesser over here. That's why this is the stable. Okay, so there is a relief in strain. This is called the strain. How much strain is there? Relief in strain after diol formation. So favorable. That means if you give the equilibrium sign, so the equilibrium sign should look like this. This arrow would be longer because this to this conversion is favorable. Okay, now the next. Question number 16. Okay, now let's take as a phenyl. Okay, so phenyl when attaches with this NaCN, so I'm not writing the mechanism we have already done it. So this is the OH and this is the CN, NaCN and HCl82O. Okay, so after that we are attaching the HCl. HCl is an example of strong acid. So when you are treating with the strong acid, at that time what happens? Because of the HCl is a strong acid has the capability to convert the cyanide to the acid. So this is OH, CO2H and the methyl. So this will be the final product in which the CN group has been converted to the carboxylic acid. Okay, I think I need another class of the bisulfite addition reaction in which I will be completing the chapter 6. Thank you so much for watching.